This is the training method or training process of the range prediction model. If we observe the first training iterations of the DNN range model, the training loss is high because model weights are randomly initialized, right? The total parameters, the training parameters we used it around 27k, and the non-trainable parameters around 448. The validation loss is already lower, showing the model quickly learning EV range relationships. And when it comes from epoch 5 to 15, by epoch 5, both training and validation errors are dropping significantly. This indicates model is successfully learning nonlinear battery to range mapping. The small MAE shows predictions are getting closer to actual range values. And by the mid of training, the model stabilizes and converges. Training and validation losses are very close, meaning no overfitting. The model now predicts AV range with very small error. At final epochs, if we observe, final epoch shows very low loss indicating high accuracy. Validation MI is extremely small, meaning predictions are very precise. The model restores best weights for optimal performance. DNN range model performance. This shows performance of the deep neural network alone. MI is around 1.2 km, means predictions deviate by 1 km on average, and R square score is around 0.991, indicates the model explains 99% of the range variation. And for the GBM range model, gradient boosting model performs extremely well on structured data. MI is nearly 0, meaning predictions are very close to actual values. R square is 0.999, indicates near perfect predicted accuracy. And the blended ensemble performance, this combines DN and GBM predictions using averaging, improves generalization and reduces overfitting risk. And the final R square score is 0.9979, shows very high EV range prediction accuracy, around 99.79%. This is the saved plot outputs of our EV range predictions. This first plot shows actual versus prediction EV range comparison, and the second plot visualizes SOH degradation and RUL curves. SOH degradation and RUL curves. These plots helps validate model performance visually. And the pipeline summary and the evaluation matrices, if we observe, the SOC estimation is, the table summarizes the performance of all battery intelligent modules. SOH, RUL and range models show high accuracy with R square above 0.97. Here the SOC estimation R square score is very less and it is negative because of the scaling feature or the parameter scaling. These parameters are very low number, so that is why R square is not performing well here compared to the other submodels. And models show the higher accuracy with R square is above 0.9 for the other models. And EV range model performs the best with R square score is around 0.99. And finally, this demonstrates real-time interference using trained ensemble model. A single battery input is given to predict driving range. The model estimates the EV can travel 253 kilometers on current battery state. This is our whole model with the integration of anomaly, removing of unwanted data, and with the first submodel SOC, second SOH and RUL. At final we are predicting the range of the battery on the base of battery state.